Hello friends, welcome to my channel K10 ESC Aspirants. In this lecture, we will quick revise the fluid properties. Fluid properties. Properties are certain measurable characteristics that can be quantified with the help of property. It means we can identify a fluid. The fluid properties are density or mass density, specific weight or weight density, specific gravity, compressibility, vapor pressure and cavitation, viscosity, surface tension, capillarity, pressure, temperature, thermal conductivity, speed of sound, specific heat, etc. Let us start with the first property of fluid, which is density. Density is defined as the ratio of mass per unit volume. Its unit is kg per meter cube. Number of molecules represent more the mass. If more the mass, it means heavier the fluid. Hence, density represents the heaviness of the fluid. Density is equal to say mass per unit volume. Masses represent the molecules. That's why density represents the heaviness of the fluid. Its dimension is ml the power minus 3. Density of solid is more than the density of liquid, and density of liquid is more than the density of gas. Let us consider a container in which solid is filled. Solid is closely packed crystalline and non-crystalline structure and hence more number of molecules inside the container. In case of liquid, molecules are not closely packed, so less number of molecules inside the container. In case of gas, molecules are not closely packed and not in mannered order. That's why it has the least number of molecules inside the container. Density of water is 1000 kg per meter cube at 1 atmospheric pressure and 4 degree temperature, and it is 998 kg per meter cube at 1 atmospheric pressure and room temperature, and density of air is 1.21 kg per meter cube at 1 atmospheric pressure and at room temperature. Now second property is specific weight. A specific weight can be defined as the ratio of weight of the fluid to its volume. Basically, specific weight represents the force exerted by the fluid due to gravity in a given volume of fluid. A specific weight is equal to say weight per unit volume. So weight can be written as mg per unit volume, and m by v can be defined as a density. So specific weight is equal to say rho into g. Dimension of a specific weight can be defined as ml the power minus 2 t the power minus 2. So weight of the fluid can be defined as the specific weight into volume. So weight can be defined as rho g into v. Here key point is density is the absolute quantity with respect to location, whereas specific weight is variable quantity with respect to location. Now third property is specific gravity. A specific gravity can be defined as the density of fluid to the density of a standard fluid. It is a dimensionless quantity. A standard fluid in case of liquid is taken as water, whereas in case of gas it is taken as air. A specific gravity basically represents which fluid is lighter and which fluid is heavier. If specific gravity is less than 1, it means it is lighter than water. If it is more than 1, then it is heavier than water. If it is equal to 1, it means it is the water. Relative density can be defined as the ratio of two densities. Here key point is all specific gravity are relative density, but all relative density is not a specific gravity. Now fourth property is compressibility. If there is change in volume and density with respect to pressure, such a fluid is compressible. Liquids are incompressible, whereas gases are highly compressible. Mathematically, compressibility is defined as the reciprocal of bulk modulus of elasticity. Beta is inverse of K. Density is equal to say mass upon volume. Mass can be written as density into volume. M is constant. Differentiate both sides. If mass is constant, it is differentiate is equal to say 0. So 0 is equal to say rho dV plus V dP. If we differentiate and after equating, we get minus dV upon V is equal to say d rho upon rho. Bulk modulus can be written as hydrostatic stress upon volumetric strain. So K is equal to say minus dP upon dV upon V. K is equal to say minus V dP upon dV. So K can be written as rho dP upon d rho. Negative sign represent the compression of volume. Compressibility is equal to say 1 upon bulk modulus is equal to say minus dV upon V dP is equal to say d rho upon rho dP. The key point is beta is equal to say 0 and K is equal to say infinite for ideal fluid. Because ideal fluid is incompressible in nature. Isothermal bulk modulus. Isothermal means temperature is constant. Let us take an ideal gas equation. PV is equal to say mRT, P is equal to say ρRT. It is differentiate with respect to density, so dP upon d rho is equal to say RT. So put this value into the bulk modulus equation. So we get KT is equal to say rho dP upon d rho is equal to say ρRT. So ρRT can be written as P. So isothermal bulk modulus KT can be written as pressure. Adiabatic bulk modulus Ka. Adiabatic means heat transfer is 0. So Q is equal to say 0. Now take adiabatic equation. P v the power gamma is equal to say constant. Volume can be written as mass upon density. So P m upon rho the power gamma is equal to say constant. So P upon rho the power gamma is equal to C upon m the power gamma. P upon rho the power gamma is equal to say capital C. Because mass is constant, so right hand side is become capital C. So P is equal to say capital C multiplied with rho the power gamma. Differentiate pressure with respect to density, so we get dP upon d rho is equal to the C into gamma into rho the power gamma minus 1. Put this value into bulk modulus. So Ka is equal to say rho dP upon d rho is equal to say C multiplied with gamma into rho the power gamma. So C multiplied with rho the power gamma is written as P. So Ka can be written as gamma into P. So adiabatic bulk modulus can also written as gamma into P. Key point: from adiabatic bulk modulus and isothermal bulk modulus, we can conclude that compressing the gas adiabatic is more difficult than compressing isothermally, because in case of adiabatic there is no rise of temperature. Due to this, randomness of molecules is more, and hence it provides resistance to motion. From this, we can conclude that on increasing pressure, bulk modulus increases and compressibility decreases. That's all for today's lecture. In this lecture, we have covered 4 properties of fluid, and rest of the property we will cover in next lecture. So thank you. Hope you like the video. Please comment, subscribe and share the video.